In last class we discussed about the silicon control rectifier. In that we studied the construction of silicon control rectifier, operation and characteristics of silicon control rectifier. Along with we studied the applications of silicon control rectifier SCR. Today we will discuss about the UJT unijunction transistors. In this we will discuss concept of UJT and construction working of UJT. Then after we discuss the characteristics and applications of UJT. The name itself having unijunction. UJT stands for unijunction transistor. So the name itself we are having unijunction means only one junction. So when we having only one junction, so like diode we had two terminals, but here like transistor we are having three terminals. So this UJT is a three terminal device but only one PA junction. Coming to the construction, you can observe in the figure A, it consists lightly doped n-type silicon bar and heavily doped p-type semiconductor is implanted in the n-type bar. So due to that, it forms the one PN junction. From the lightly doped n-type silicon bar, we have taken the two terminals that are base 1 and base 2, we are named as B1 and B2, and one more terminal, emitter terminal, which is taken from the heavily doped p-type material. So we are having lightly doped n-type material provides the two terminals that are base 1 and base 2. Heavily doped p-type material provides the one terminal that is named as emitter E. Yes. So base 1, base 2, emitter are the three terminals of UJT. Here n-type bar is lightly doped one and p-type region is heavily doped one. So the charge carriers in the n-type is less compared to the heavily doped p-type region. Yes. So here the circuit symbol of unijunction transistor is represented in the figure B. So it's like a transistor, it has three terminals but emitter terminal little tilted here. Yes. And its equivalent circuit is represented in the figure C. It forms the one PN junction, so it's nothing but a PN diode. So here it is represented with the PN diode. So emitter terminal is connected to the anode of the PN diode. Yes. And the cathode terminal is connected to the two resistors RB1 and RB2. This RB1 and RB2 are the two resistors offered by the n-type silicon bar. This RB1 resistance is closer to the base 1 terminal. RB2 resistance is closer to the base 2 terminal. Yes. So voltage applied at the emitter is VE. Voltage applied between the base 1 and base 2 is VBB. So voltage drop across the RB1 is nothing but voltage of cathode terminal of diode. Yes. So voltage drop across the RB1 can be written as what we can write RB1 by RB1 plus RB2 into VBB from the voltage divider. Yes. So anode voltage of the diode can be represented with VE. Cathode voltage of diode represented with the VA or voltage drop across the RB1. Yes. The total resistance offered by the UJT when diode is off state can be written as sum of RB1 plus RB2. Yes, this resistance is called interbase resistance. It is represented with the RBB. RBB equals to RB1 plus RB2. Yes, when diode is in not conduction, that means IA equals 0, the drop across the RB1 can be written as VRB1 equals to VBB into RB1 by RB1 plus RB2. So the ratio RB1 by RB1 plus RB2 is represented with the eta. The eta is intrinsic standoff ratio. Yes. So this intrinsic standoff ratio generally lies between the 0.5 to zero point 0.8. Then working of UJT. So the biasing is applied by using the two batteries. So one battery is used to provide the VBB. So the positive terminal of the battery connected to the B2 terminal and negative terminal of the battery is connected to the B1. And one more battery is used to provide the VE voltage. So the positive terminal of the battery is connected to the anode terminal of the diode and negative terminal of the battery is connected to the B1. Yes. When the diode is in conduction, then UJT is in turn on. When the diode is in off state, then UJT is in off state. So here anode voltage of the diode is VG and cathode voltage of the diode is nothing but voltage drop across the RB1. It is named as VA. Yes, when anode voltage is greater than the cathode voltage, then diode will turn on. Otherwise, diode is turned off. That means we are dividing into two cases. One is anode voltage is less than cathode voltage, and second one is anode voltage is greater than the cathode voltage. First one, VE is less than VA. It means anode voltage is less than VA means drop across the RB1 resistor. So in this case, as long as VE is less than the VA, the PN junction is reverse bias. Yes, when the diode is in reverse bias, hence we can say undercurrent will not flow in this diode. Thus we can say UJT is turned off state. Yes, but in this state we had a reverse saturation current. Why? Because when the diode is in reverse bias, so we had a reverse saturation current. It is represented with the IG0. In second case, that means anode voltage is greater than the cathode voltage. Yes. So here cathode voltage is VA and drop across the diode is represented with the VD. Anode voltage is VE. So VE must be greater than the VA plus VD. Yes. Otherwise, here we represent the sum of VA plus VD is VP. The diode voltage VD and voltage drop across the RB1. The sum must be less than the VA value. Then only diode will turn on. Yes. So this VE, when VE is greater than the VP or equal, then the diode PN junction becomes forward biased and current flows through the current IE flows in the circuit. Yes. Due to this, when the diode is in forward bias, what happens? The charge carriers are injected in the RB1 region. When the diode is in forward bias, holes are injected into the n-type bar and electrons in the n-type bar are injected into the p-type. Yes. So injected holes in the n-type bar are always moving towards to the B1 terminal because that B2 terminal is connected to the positive of the battery. So the injected holes are always repelled by the positive of the battery, and that are always accumulated towards the B1 region. Yes, due to this, the conductivity of B1 region increases and resistance will decreases. Yes, so when you are increasing more forward bias, then what happens? The conductivity of base 1 region, B1 region, will increase and resistivity will decrease. Yes, under this condition we can say UJT is on state and it remains in this condition till the input is open or emitter current gets reduced to very low value. Yes, so the device is on state when emitter is open or emitter current reduced to very low value. Yes, here we can observe the characteristics of UJT. In this, we draw the characteristics between the emitter current and emitter voltage. Yes, so in generally, in all the characteristics, the voltage is always taken in the x-axis and current is always taken in the y-axis. But here it is, we are taken in reverse. In x-axis, we are taking the emitter current, and y-axis we are taking the emitter voltage. Yes, up to the peak point voltage, that means VA plus VD, the UJT is always in off state. Yes, so in that case we are having the only reverse saturation current because the diode is in reverse bias. Yes, so it is represented with the IE naught till the VP. Once emitter voltage reaches to the peak point voltage, what happens? Once emitter voltage reaches to the peak point voltage, the diode starts the conduction and holes are injected into the N layer. Hence, the resistance decreases, thereby decreasing in the emitter voltage for increasing the IA value. Yes, once emitter voltage reaches to the peak point voltage, what happens? Diode starts the conduction, then holes are injected into the base 1 region, the conductivity will be increases, resistivity will be decreases. Yes, then emitter current will increase and it decreasing the VE value, increasing of IE value. Yes, so in this, once we reaches the peak point, the current will increase and emitter voltage will be decreases due to the large number of holes accumulated at the base 1 region. Yes, so current IA increases, VE decreases, so we can say it is a negative resistance region. Yes, once it reaches to the small value of gate voltage, then what happens? Again, it performs the normal operation of the diode. Yes, so the maximum applied emitter voltage VE to turn on the UJT is called peak point voltage. Yes, peak point voltage is nothing but the voltage required to turn on the UJT is nothing but peak point voltage. It is nothing but sum of diode voltage and drop across the RB1 resistor. Yes. Once it reaches to the peak point voltage, the UJT will turn on. Yes. And this, in conduction state of UJT, IE will increase up to the value point of current. In this point, this emitter voltage will be decreases. That voltage is represented with the value voltage VB. Yes. After reaching the value point, value voltage, then now the UJT will work as normal diode. Yes. So before the peak point, we can say it is cutoff region. In the peak point to value point, we can say negative resistance region, and third one is saturation region. Yes, in cutoff region, this Vg is less than the Vp, so P initial is reverse bias. We know that reverse saturation current will flow in this device. In the negative resistance region, when emitter voltage greater than the Vp, P initial becomes forward bias, I starts flowing, then voltage across the device will decrease. Means VE will decrease in this region, current through the device increases. So it is called neutral resistance device. In saturation region, increase in the IA further value point current IV, it drives the device in the saturation region. The voltage corresponding to the value point is called value point voltage. In this region, further decrease in voltage does not take place. The characteristic is similar to the normal P junction diode in this region. Yes. This usually used in the triggering circuits. So to turn on the SCR, we need to trigger the SCR, serial control rectifier. The triggering will be given by the UJT. So these UJT circuits are used to trigger the SCR, and these unijunction transistors are generally used to generate the different types of waveforms. Mostly we use the sawtooth waveform generator and relaxation oscillator circuits, and some of the timing circuits, and these UJTs are used in the automobile ignition circuits. Thank you.